The most common question on the MCAS relates to the differences between, or a difference between, a mechanical wave and EM wave. You'll always be asked for one difference, perhaps twice or three times in the test. You could also be asked for two differences, so this video is about two differences between mechanical waves and EM waves. The first difference, and the most important one by far, has to do with mediums. Now, a mechanical wave needs a medium to travel. This medium here needs the rope. Without it, there's no medium. There's no wave. Over here, this wave needs a slinky for its medium. Without that slinky, no slinky wave. Same here. No medium, no slinky wave. Same here for water. No water wave. It's a bit more complex down here because we can't see it, but this guy's yelling and his sound is reaching your ear because it's traveling through air. There is a medium. So mechanical waves must have mediums or they will not travel. Now that's very different, isn't it, from EM waves? Two classic examples here. We have the sun, we have the vacuum of space, no medium, but still, even though there's no medium, visible light and UV light can make it to Earth. They travel through the emptiness of space. They do not need a medium, and they're EM waves, aren't they? Another classic example is communicating with a satellite via radio in outer space. The waves here are radio waves, EM waves. But here we have the emptiness of space, a vacuum again, no medium, and those waves can travel through. So there you have it, the first and the most important example, the difference between an EM wave and a mechanical wave, and you must know this difference. You could be asked it, well, at least twice, maybe three times. The difference is mechanical waves must have a medium. Here, if you take that air away, no medium, no wave. Over here, with an EM wave, no medium, no problem. It's going to travel right on through. That's the most important difference. Now, there's a second difference you can use if you're asked for two, and that has to do with how fast waves move through the same medium. Let's read this here. Different mechanical waves travel at different velocities in the same medium. Of course, that's for a mechanical wave, right? These are mechanical waves. So let's see here. We have this medium, this slinky, and this transverse wave is traveling at 15 meters per second. Right after it, we have the same medium, the slinky, but a longitudinal wave where he's pushing on it. Let's say that travels slower. I kind of made those numbers up, but here's a real number. If this thing's made of aluminum, you hit it, and you're listening for the sound which goes through it, which is a mechanical wave, right? The aluminum is 6,320 meters per second. So the story is, in the same medium, mechanical waves do not travel the same velocity. Their velocities can differ. Well, how about electromagnetic waves, EM waves? But down here, and this is from your formula sheet, it says the speed of EM waves. It gives you a single number, doesn't it? This is really in air. They don't really say that. This is in air. But in air, all these waves, all 7 of them, travel at the very same velocity. And that's true of other mediums too. Different speeds, but the same. Okay. So to summarize, there are two important differences between mechanical waves and EM waves. And by the way, here's your video code. Difference 1. There are two important differences. First, mechanical waves must have a medium. EM waves do not need a medium. 2. Mechanical waves will travel at different speeds or different velocities in the same medium. EM waves, nope. All the way from radio to gamma, travel at the same velocity in the same medium. Bye.